Hi, I'm Mary, and this is another magical math moment. This video is for our Algebra 1 students who are seeing quadratic functions for the first time. We're going to be looking at standard form, how to find a vertex, the equation of the axis of symmetry, discuss minimum and maximum function values, as well as domain and range. There's a lot to do, so let's get to it. Before we start looking at how these functions can change, let's go ahead and look at the parent function y equals x squared. So if we choose some x values to substitute into this equation, we'll start with -2. -2 squared is +4. We'll repeat this with all of our x values. Notice that the y values are repeating in some places. So -2,4 is this point up here. 2,4 is this point here. Notice that they are equidistant to the y-axis, which also serves as the axis of symmetry. It's the line over which the function is a mirror reflection of itself. Notice with quadratics, they have a little bit of a curve to them, and the shape is called a parabola. So whenever you've got your U-shaped type of curve like this, that's a parabolic shape. The minimum point in this case is a vertex. We'll also see ones that are maximums. When you're given a function written as ax squared plus bx plus c, that's considered standard form. They're going to use y and f of x or g of x interchangeably. So whenever you see f of x, f of t, anything like that, that just means y. To get the x coordinate of the vertex, we're going to use the values for b and a and substitute them in to the expression -b over 2a. That will give us the x value of the vertex, which we then substitute back in for x to find the corresponding y value. So let's try one and see how it goes. All right, we've got f of x is 2x squared minus 12x plus 8. So our a value is 2, b is -12, c is 8. To find the x coordinate of the vertex, we need to figure out the opposite of -12, which will give us a +12 on top. Negative turns positive. On the bottom, we're multiplying 2 times the a value of 2, which is 4. 12 divided by 4 is 3. Now we're going to go back to the f of x function rule to figure out f of 3. So we're just going to replace all of the x's with 3. We're just going to take that and put that in for the x values. Okay, so next we have 2 times 9. -12 times 3 is -36, and 8 is at the end. This will give us 18 minus 36 plus 8. I like to combine the positive things, so 18 and 8 is 26. 26 minus 36 is -10. That means our vertex is the point 3, -10. Okay. Let's do a quick sketch of this thing. We're going to go over 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we are. Now, another point that is on this graph will always be your c value. That's the y-intercept. Unfortunately, this is +8, which is like way up here, so that's going to be tough for us to sketch. Another way that you can graph this is in regard to using the a value over 1. So you can kind of think of it like a slope, even though quadratics don't have slope. So from this point, we would be going up 2 and over 1 in each direction. And then we can do just kind of like a little quick sketch here. Again, if you've got technology like a graphing calculator or Desmos, that will help you in getting more points, or you could make a table. The axis of symmetry is the line x equals, not -3, +3. That's always going to be the same as the x value of your vertex. Okay, let's try another one. We have g of x equals -1/2 x plus 3 minus 7. So the x coordinate of the vertex is the opposite of b over 2 times a, which is -1/2. So we're going to have -3 on top divided by -1. Half of 2 is 1. The negatives will cancel, and again, we get 3. Why did I do 2 of these with the x value 3? I don't know. It just worked out that way. We've got negative 1/2 times 3 squared plus 3 times 3 minus 7. So I'm just gonna kind of go through the math here. Oh, I forgot my squared. Don't want to forget that. Okay, so let's see. I have negative 1/2 times 9 plus 9 minus 7. All right, this is negative 4.5. 9 minus 7 is 2. That's going to give us negative 2.5. I know a lot of times y'all don't like dealing with decimals or even fractions. So, you know, unfortunately, you're going to have to encounter that. So let's see if we can figure out what's going on here. We're going to 3. Oh, this is not a very even scale. Negative 2.5. So halfway between negative 2 and 3. Now the A value is negative 7. So if I'm here at negative 2.5, here's negative 3, negative 4, 5, 6, 7. I can plot that point. I can do this first half of my curve. I also have that vertical line that goes through here and acts as that axis of symmetry. This is x equals 3. Since I have a distance of 3 here, I can also go a distance out 3 here to get another point. And I can go like that. So if I'm at 3 and I'm adding a 3, I actually end up at the x value 6. So 6, negative 7 is also a point. In regard to max and min, those are the highest or lowest points respectively on the graph. They are written in terms of y values, so we need to keep that in mind. So if I'm looking at the f of x, the first graph that we did, let's go back to it. That's a minimum value of negative 10. Min of negative 10. For g of x, the graph that we just did up here, we have a max value of negative 2.5. The last thing to talk about are domain and range. Remember, domain are the x values of a function. They go left to right. For every quadratic that you will encounter, it will have a domain of all real numbers, which is the same thing as this goofy looking symbol, right? The range will go bottoms up. So when you're looking at them, let's look at f of x and g of x real quick. Trying to keep this a little short for you guys because I know it's a lot of information. If I'm looking at f of x, I'm here. The y values are above, so y is greater than or equal to negative 10. The range equals y greater than or equal to negative 10. When I'm looking at the g of x function, the y values are defined underneath that max value, so I will say that the y values are less than or equal to negative 2.5. I know this was a little quick at the end. I'm trying to keep these as short as I can because it is a lot, but I don't want to talk too slowly. I hope this has been helpful for you. Don't forget to come back and check out information on vertex form and intercept form in later videos. Thanks for watching, and I'll see you next time. Bye.